Let's solve for x here, where x is defined in this domain. Now, how do you go about doing this? The first thing is to equate the trig ratios. If you want to deal with sine throughout. If you want to deal with cos, you can change sine to be in terms of cos. So otherwise, the trig ratios must be the same. So how do you go about changing the trig ratio of sine to be in terms of cos now? The first thing is to actually remember that if you have cos x is the same as sine 90 minus x. So this is how cos x is defined according to trig ratios, because when you are having 90 there, the trig ratios has to change to be another one. So if you are having sine 90 minus 2x, so the answer will be just cos this angle, which is what? Which is 2x. So this is what you have to remember when you are changing the trig ratio to be another trig ratio. So this is what you have to do. So here I prefer to change the left hand side to be in terms of sine. So how do we do that? And then we are going to be having sine 90 minus 2x. So we have changed this whole thing to be in terms of sine, just that way. So this one, let's just keep it this way, and nothing to be changed there. Now, what do we do after the trig ratios are the same? When the trig ratios are the same, that means the angles themselves has to be the same as well. Because remember, when you are having sine 60 this side, it is equal to sine what? So when the trig ratios are the same, the angles has to be the same. It has to be sine 60, none other than that one. So which means this is what we are going to be doing by equating the angles after the trig ratios are equal to each other. Now, what are we having? We have 90 minus 2x. It has to be equal to this angle on this other side. So this is x minus 30. So once you have this, you really have to add 360 k, where k is an element of integers. So we are going to be using this element of integers. You can even be specific that k is an element from -1, then 0, then 1, 2, 3, 4, 5. Otherwise, these ones are there. They are likely to be true to the domain that usually given. Now, let's solve the value of x now. Let's take this x to that side. You'll be having what? You'll be having -3x, which is equal to, let's have -30 minus 90, which is just going to be -120, then plus 360k. So we'll have to solve the value of k here. So when you divide by -3, you will then get just positive 40. Then it doesn't matter whether you change the sign or not, but because you are having the constant value k there, that is going to change anything anyway. So 360 divided by 3 is going to be 120. Just know that this 3 also affect this value over there, so that you are having now the period that is just changed. So this is your first equation, or this is your first general solution for sine, and you know that sine is found in the first quadrant and on the second quadrant. So how do you get into the second quadrant? You just have to remember when you were adding this 360k here, this must be treated as the reference angle. So this whole equation, this step must be working on finding the second general solution. So what are you having? You have this side, which is 90 minus 2x, which is equal to, how do you get into the second quadrant where sine is positive? Because remember, we are dealing with sine. So we say 180 minus our reference angle, which is x minus 30, and don't forget to add 360k there. Now we are going to be solving the value of x here. So let's just first find a way to clear up the right hand side. Then we have 180, then minus x, then plus 30, then plus 360k. Now, how do we then collect the like terms? When you take this negative x to that side, you'll just have negative just x. Then therefore on the other side, we have 180 plus 30 minus 90. then that is going to be just your negative 120. This is going to be, yes, this is just going to be 120, not negative. So you have plus 360k. So after that, you'll be having just negative 120, then plus 360k when you divide by a negative number. So these are your two general solutions for this equation given over there. So you have to now mind about the interval, because you are actually looking for the values of x, not just general solution. If the question was to ask you to find the general solution, you would be done by now. But now they are being specific for you to find the actual values of x. Solve for x. You are solving x. X is equal to this. X is equal to this. But because of this one now, because of k there, this solution is general, not specific. Now let's be specific by finding the values of x using the first general solution. Let's find this one, and you are going to get x is an element from so you can just say x is equal to the set of these values. Now we're having 40. We're using this equation 40 plus 120, then times, let's use negative 1 for the value of k. We get negative 180. I think negative 80, not 180, is part of this domain that is given over there. So this is negative 80 is part of the solution for x in that domain. Now let's put 1 in the place of k. Remember, we are substituting by the values of k upper. So these values, which is the integers that we were discussing about. So in the place of k, we put those integers to find the actual values of k in that interval. So let's put 0 there. You will actually get exactly 40. You have 40 there. Then therefore moving to putting 1. When you put 1, you get 160. 160 is part of this, because 160 is less than 180. So we have 160, which is part of the solution. Let's put 2. 2 is giving us 280, which is not part of the solution. Now I think we have found all the values that are satisfied by this general solution over here. So let's come to the second general solution, which is this one, and substitute by the integers in the place of k to find the actual values of x. Now we're having negative 120, then plus 360, then times negative 1. You actually got negative 480, which is not part of the solution. Let's put 0. Negative 120 still. When you get negative 120 is part of this solution, because it's really greater than negative 360. Negative 120 is a part of the solution. Let's put 1. When you put 1, you get 240. So I think these are just the solutions for those that general solution, that equation. So if you are to insert these values into that, the left hand side will definitely be equal to the right hand side. So thank you for watching. See you in the next video.